Hey everyone, got another coding challenge here. This one's a bit of a doozy. It says here, good morning, here's your coding interview problem for today. This problem was asked by Google. Suppose we represent our file system by a string in the following manner. The string, so I won't read it, but you guys can see represents, and then, so these two, this is like two representations of the same data, right? This is the raw string with /n for new line and /t for tab. And so here we see the new line, and then we see a tab here. Notice after subdir 2, there's a new line, and then two tabs, like tab, file. So here's subdir, new line, tab. The directory dir contains an empty subdirectory subdir1 and a subdirectory subdir2 containing a file.ext. The string blah 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 represents this stuff. The directory dir contains two subdirectories, subdir1 and subdir2. Subdir1 contains a file1.ext and an empty second level subdirectory subdir1. Subdir2 contains a second level subdirectory subdir2 containing a file2.ext. We are interested in finding the longest, in terms of number of characters, absolute path to a file within our file system. For example, in the second example above, the longest absolute path is dir. So I hesitate here because I just noticed they don't start their root with a slash, which is a little interesting, but anyway. Dir /subdir2 /subdir2 /file2.ext, and its length is 32, not including the double quotes. So I'll just take the words for it. I'm not actually going to count out those characters. Given a string representing the file system in the above format, so I guess I mean given a string like this, return the length of the longest absolute path to a file in the abstracted file system. If there is no file in the system, return 0. Notes, the name of a file contains at least a period and an extension. The name of a directory or subdirectory will not contain a period. So yeah, so this is quite an involved problem. I think it's multiple phases. And so I'm not going to do a random language because it's so involved. I'm picking a language. I'm going to do it in Kotlin. So why do I think it's involved? I think there's at least two phases to this problem. Maybe there's more. I try not to pre-think about the problem too much before I start the stream. I want you guys to see my thought process live. So that's why I'm not sure how many phases this problem is going to have yet. I haven't fully thought about it. But there's going to be at least one phase, which is a parsing phase, right? Like I'm given the string here, and I need to parse this to construct like a tree data structure, basically, right? Like that represents the file system. That's the first phase, and I think that's going to be the more involved phase. The second phase is once I have this tree data structure, I'm going to want to, I guess I'm going to want to it says they only care about files. I guess they don't care about, they say they want the longest absolute path for a file, so not a directory. So I guess once I have a tree structure, I'm going to convert to a list of all possible paths or something like that, and then filter out so that I only have files and not paths to directories. And then I'm gonna map those to lengths, basically, and then I'm going to take the max length, right? So those are the two phases. So I got my little hello world here just to make sure my environment is set up. And I don't know why it's taking so long to compile it. I think I felt like I ran it recently. Yeah, here it is. So hello world works. So I know my environment is set up correctly. So now I can start tackling this problem. Okay, so how to go about this? I think what we're going to do is we're going to create some sort of data structure to represent the file system, first of all. So maybe something like create some data classes for, is it pav? Maybe I want a sealed class, of which I have a data class representing a file and No, I don't need I was thinking I need a separate one for file and a separate one for directory, but I can probably do it as just one thing. So let's just have a data ask for a file. So let me think about this. I think I want to reference a parent. Okay, so each file is going to have possibly have a parent, because like the root directory here will not have a parent. That's going to be special in that sense. And then it has a name, I guess. It's just gonna be a string. And we can get into some helper functions later on, but I'm pretty sure one of the helper functions is gonna be this directory, and we're just gonna say like if the name contains a period, then it is a file rather. Otherwise, it is a directory. So we might have other helper functions in a moment. Maybe we're gonna have like a function called like get full path, something like that, which is going to return a string, which I will implement later. But yeah, so here's our data structure. I think this is all we need for data structure. So the first step is to parse these strings into these data structures. So let's do this TDD style, kind of. I'm not going to use a testing framework. I'm just going to use asserts, I guess, maybe, or maybe throw exceptions or something like that. Tests can parse example 1. So let's see. This is going to be example 1. So I have my input. I'm going to have some parsing function. Let's see, it's going to take some input as a string, and then it's going to return a file structure, I guess. Maybe it's going to be a question mark. The reason I'm thinking of this question mark is one of the I'll put the test case here. One of the test cases is probably going to be and parse empty file system, because they explicitly give that as a possibility here, right? When they say if there's no file in the system, return 0. Empty file system, MTFS, meaning if I give this input, I expect parse of the input. Is there an expect built into Kotlin? No. Okay, so I'm just gonna say if actual equals null. Well, that's good. And if it's not equal to null, then we have a problem. Let me do an expect helper method actually. Yeah, I'll call it assert equal. Is there a assert equal that's already built in? Let me check that. Oh, there's an assert, but I think this uses the JVM assertion, like the Java style assert, which means that you can disable assertions with a JVM flag. So I don't want that. So I am going to do this with my helper. Show expected t if actual equals expected, then that's good. Do nothing, and if they're not equal to each other, runtime, or I guess I can throw assertion exception actually, assertion error. But was actual. So this were like if I were coding in real life in the sense of like for a business project, I would use a framework like JUnit and like Hamcrest or something like that. But because I don't want to set this up, I just want to make one big file to submit as the solution for this. I'm doing my own here, so I don't have to pull in any dependencies. So now that I have that helper, I'm saying I'm asserting that this is equal to null. So this is one test case. And I guess what I'll do is I'll have my my main method just run all the test case. So here's one of them. Here's another. In this case, what do I want the expected to be? So the actual is going to be whatever it is, right? I'm parsing this. File expected equals. So what is this going to be now? Let me think about this. So I'm going to have to do the parent is null, and then the name of this is dear, right? And then I'm going to create subdir1, whose parent is root dear, and whose name is subdir1. And then subdir2 also has root dear as its parent, and its name is subdir2. And then there's going to be the file whose parent is subdir2, I believe, and then whose name is file.ext. I use capital D for subdir. Okay, so now that this is fully constructed, interesting. Rootdir does not have a reference to subdir1 or anything like that, which means when I say assert that that they're equal, since none of these guys are ever referenced, the assertion can't possibly do anything useful. Okay, so I guess I don't want a parent pointer. I want a child pointer, I guess. So let's do it like this. It's gonna be, I guess, a list of children, or maybe a set. I guess we're gonna assume that the children are not sorted. Like the ordering doesn't matter. If this were a live interview, obviously I would ask them. But yeah, there's no, like, can you imagine a file system where like two directories were not equal because the order of their children were different? That seems really weird, right? So probably this is the most sane way to do it. We might even do a bit stronger assertion, which is you can't have two file nodes with the same name. That this guy doesn't enforce, but that looks like it's outside the scope of this problem, so I won't worry about it for now. And that means this helper method might not live here, because like to get the full path you want to know your parents. Since that's not possible here, this might become like a static method, or a method that lives outside of this class, but we'll worry about that later. But okay, so given this new formulation, set of, is that how I do it in Kotlin? I want to create a set of something. This guy has no children. Then subdir 2. And this guy does have some children, which is this person, or this file rather, which does not have any children. Okay, so expected is going to be equal to this whole thing here. Then I'm just going to assert equal actual expected. All right, so let's run it. I'm expecting this to fail. It's probably gonna fail with to do, right? Because I think, did I put, oh, it might not even compile. So let's put to do here, and then this will probably fail with the when it hits this line when it says there's a to do here. Operation is not implemented. Yeah, exactly. Okay, so let's start implementing this. So we can do the easy case, base case, which is if input is the empty string, we just return null. Right? Oops. So that's gonna get us past the. That's gonna make the first test pass, I think. But let's try to figure out how to implement the slightly more complicated version. So how to implement this? How to implement this parser? Let me think about this. I think we're going to want a parse that keeps track of what level in the tree it's in. Like I'll call this level 0, and then this is level 1, and then 2, 2, and then 1 again, level 1, 2, and then level 3. Yeah. Okay, so this level idea is, I think that's as simple as just counting the number of tabs. So what we'll probably do is we'll read the string, we'll split it on the new lines, and then we'll have a bunch of lines basically at that point. Then for each line, we're going to count how many tabs it starts with, and then we're going to say that's the quote-unquote level of that file node that we're looking at. Once we have that information, I'm trying to figure out now how to then assemble that into a tree structure. So one thing I could do is parser combinators, but I don't know if that's overkill for this problem. Let's start with that first step of turning this into a list of file nodes with their levels. So what I'm going to do is I'll take the input, and then I'm going to split it. Varg delimiters. What does this return? An array, a list, a char sequence? No, a list of strings. Okay, it returns a list of strings. So this is each line. And then actually I'll probably do split to sequence, because I'm gonna sequence are slightly more efficient if we're doing like this mapping type operator, not operator, but coding style in Kotlin. So now for each of those, for each line, basically what I'm doing is I'm gonna create a pair. Is there a built-in pair type in Kotlin? I just do the, yeah, okay, so then I'm going to, let me just do a to do for now. It's gonna, I need to figure out the level, which is line dot How do I count how many tabs there are? Is it, like, I'm trying to think if there's a quick and easy way to do that. Oh, I can trim it, maybe. Yeah, I'm doing a little bit of assumption that the data isn't malformed here. I don't know if that's safe to do. But if I assume that we never have like the directories can't contain spaces in our names, then I can do a trim. Or can I do drop prefix? Maybe I'll do this. I'll just say get rid of right, and maybe slightly more idiomatic is to use the it keyword here. So what I'm doing here is I'm saying for a given line, I'm saying drop all the characters that are tab, and then now I have just a name, right? So that's my name over here. And then what I can do is I can say, well, the level then is surely the length of the line minus the length of the name, right? And then it's the easiest thing then to, should I turn to a list at this point? Or do I need to do more processing on this? I think I want a list at this point, because now that I have this list, I want to turn this list into the tree structure that we have set up over here. How to do that? So first of all, I'm going to check that well, I guess I want to make sure it's not empty. If this thing is empty, then we're going to return null. And maybe that handles this case also. Like maybe I don't need this special thing here. Oops, did one line too many. Let's run this to check. Yeah, so I think the first test pass, and like to be extra sure, I can comment this out to check. Oh no, that didn't work. Wait, does that mean this is not empty? What the heck is can I add a debugger here? How the heck, what the heck is the value here? Lines of level is size 1, and what is the single? Oh, interesting. So it thinks that the, okay, is that going to be a problem? Let's just bring that statement back. I guess that means this can never hit. If I have a string at all, then I will always have at least one entry. Okay, so now let's see. I want to check, I guess the other thing I want to check is the first guy had better have level 0. So I'll throw assertion there. I'm trying to think. There's actually another edge case. Like there's an example that they didn't give, which is what if if there's two root directories? Like you have dir here, and then you have like dir1 and then dir2 at the top level. The thing is, because they don't have a slash here, like or I guess they don't have a slash here. Like I was expecting, you know, like on the Linux style system, you have a slash here to represent the root directory. So there is one root directory, but they don't have this concept here. And I'm thinking it's a slightly odd way to structure a file system, but that might mean that the more intuitive way to model this is returning a list of all the top level directories in a sense. And so here I just return an empty list to represent that there is no like if you, for the empty string, we just have no directories, no files, no directories. That's going to cause here, this should be the empty list now. So yeah, I think at this point I am going to use a parser combinator. I think that's the most elegant way to do it. So the way we use a parser combinator, actually, it's a bit fuzzy in my mind. I don't remember the theoretical underpinnings behind that, but the basic idea, I think, is I'm going to have a parsing function that takes one of these lists of pair of int string, and then it's going to return a list of file. It's going to return. Do I have the iter here? I don't have iter, do I? Do I want to return a pair? I'm worried I'm overloading pair now, so that it's confusing about what each pair means. But so I think the idea is like this tries to parse as much as possible, and then it returns whatever it was unable to parse, like the remaining input that did not get parsed. And so I guess what it's going to do is, well, okay, so first it's going to say the base case, which is if you give me an empty list, then I'm going to return, I'm going to say this parses to an empty list, and the input is also empty, like to a pair of empty list and empty list. The first empty list representing that this parses to the empty list, and the second saying that we fully consume basically the input. So that's the base case. Otherwise, I'm going to say, well, I can infer what my level is by finding out what the first guy is in the input. So now I know my level, and then I'm going to find out let me think about this. This is, I want to keep parsing until I find another element that's at my level. Maybe I'll call this parse at expected level. Maybe that's, and rather than infer my level, I'm gonna expected level. Rather than infer my level, I'm gonna have the caller pass it in. Okay, so if the input is empty, then we weren't able to parse anything. And also, if the first element, so I guess I'll call it first line equals, where is it? What did I call it? Input dot 0. So here's my first line. If the first line dot, if its level is not equal to my expected level, then I also was unable to parse anything. Otherwise, if it is at my level, if it is at my level, then I want to parse every subsequent line. So can I say so here's, maybe I'll put it up here. First line, all other lines, right? I want to parse all other lines, parse at expected level, at my level +1, right? Basically, I'm parsing all the children. All my children, basically all the children of the place that I'm at. And so then I return no, wait, not yet. I'm because there may be siblings, which I also have to return at this point, I think. Yeah, so actually I might call this parse 1 at expected level. Parse 1 node at expected level. And so this is going to return possibly a file, and then, you know, the rest to be parsed. So if there's no input, that means there was, like, I couldn't parse into a file. If the first line's not at the expected level, I'm gonna say there was nothing for me to there was no how do I say it? If the first line of the input isn't at the expected level, hopefully, and I might do a warn here, or maybe I'll just do an assertion for now. This line first, I'm expecting it to be less than, so if it's greater than my expected level, in a case where to this guy has a greater level than expected. I don't know if you guys are following along. It's like I'm not explaining myself very well, and like, because I don't have my thoughts arranged clearly for presentation. I think I know what I'm trying to do, but it's tough to explain it and do it at the same time. The basic idea is that given some input, like given some input like this, right, where this is the root, this guy is at level 1, so he's a child of this one, this is level 2, so this is a child of this one, and then this went back to level 1, meaning so this guy is not a child of this one, of file 1 exe, it's a sibling of subdir 1 and a child of this guy. So this is what the input looks like, and what I'm trying to do is I'm trying to say, like, if you give this as a list, meaning let's say somehow you've already parsed the first line and now you're parsing the rest, you would say the expected level is 1, and this method would parse this far, and then it would return this as the remaining input to be parsed, you know, in another call somewhere. And so the idea is if I'm here and I say I expect, let me actually remove this because I think this is a more interesting case. So let's say subtier 1 doesn't have a children. So if I'm here, I wanna when I'm looking, if this is my first line, I want to say potentially this might have children. So I want to parse the next line at the expected level 2, like, you know, my level plus 1, to find all the children, right? Everybody who's at level 2. So when I get to this point, this is not level 2, it's level 1. So I say, oh, okay, so I guess that means there are no children for this guy. That's like, you know, that's how I would reason it as a human. And so that's what this code is trying to do here. It's trying to say, like, I expected level 2, but here I see the level is 1, so that means there are no children. And notice that the actual level of the line that I parse, 1, should be lower than the expected level. Like I was expecting 2, but I saw 1. It'd be very weird if I expected 2 but then saw 3. Like that would be equivalent to this situation, right? Where I said, okay, I'm gonna look for the children of this guy, so let me parse the rest of the input at expected level 2. I get here, I'm just like, okay, I'm expecting level 2, but then I see level 3. So that's what this to-do is about. Like, it's basically gonna blow up at this point. So I don't think it's possible. Like, I don't think in any valid file system this line should ever be hit, but if it does, we have this to-do that'll help us catch that issue. So yeah, so I'm also gonna have this other method here that basically has the signature of the method I had before. So this guy parses all the siblings. I guess I can put parse all siblings at some expected level. And so the idea here is that this does return a list. So using the same example here, if you were at this point in the input and you said expected level 1, then it wouldn't just parse this guy. It would return a list of size 2, where the first element is this guy and the second element is this guy, right? Where it's this guy with this as his children, as his child. And so combining, I'm gonna put to do here because I have to implement this. But so this parses one node. So if you're at this point in input and you say expected level 1, it's gonna return this guy, and then it's not gonna, like, it's gonna say the one file that parse is this guy. It's not gonna return this as the in the parse portion. It's gonna return this in the unparsed portion. So this guy builds upon this guy, but they're mutually recursive in the sense that here I do want all the children at as like, you know, parse all the siblings together. Meaning, for example, if I had I call it file a.ext and then file b.ext. If I'm at this point in the input and I say expected level 1, so I'm gonna say this is my current guy, and then I want to parse all the children at level 2, not just the first one. I will get all of these as a list. So that's what this is. And then I'm going to return my parsed thing. So my parsing is, it's gonna be a file where the name, so let me put some temporary variables whose names document what they do. The name is going to be the first line, that second guy here, and the children, it's going to be this. Is this not correct? Oh, it wants a set. Okay, so these are going to be sets. This is going to be a set. this is the portion that we did parse, and then the portion that we did not parse is here. Whatever this guy failed to parse, that's what we say we failed to parse. And yeah, so I think that completes this method. So now, given that this exists, this parser fragmented, or this parser combinator exists, how do we implement this guy? So if we're at some level, like if we're here and you're giving me level 1, then I want to return a list of all these guys. So what I'm going to do is I'm going to say, I'm going to create a mutable list, I guess. Val Sheridan parsed so far equals mutable list. So or mutable set, actually. And then I'm going to say, can I parse wherever I am? I guess I'll use a var here. So current input equals input. I'm going to say after and parse portion. No, what am I going to say? Parse all. No, parse one node at the expected level using my current input. Parse result. Okay, so now, was I able to parse anything? I'm trying to think, is seeing that the left-hand side of the pair null, is that enough to know that I wasn't able to parse anything? It looks like it is. So I say, so if parse result dot first is null, that means I wasn't able to parse anything. So I'm going to return an empty set and the original input, because we weren't able to parse anything at that level. So that can happen, for example, if I'm here, or I guess a better example is if I'm here, like if somebody else, if my caller had finished parsing up until this point, they finished parsing subtier 1 and they're asking me to parse, to check for children. So they're asking me to parse at expected level 2. When I'm here, I'm going to try to parse this at level 2, but I'm not going to be able to. So I'm going to return an empty set saying there are no siblings at level 2. And the remaining code to be parsed is the same as the input. Like I wasn't able to make any progress parsing through the input. Yeah, but if parse result first is not null, that means I did parse something. I parsed at least one guy, and so then I want to continue to see if I can parse more. So if I'm here, I want to say children parse so far. I'm going to add to it. I'm going to add parse result dot first. Smartcast to file impossible because parse first is a public property defined. What? What the heck? What does that mean? I've never seen that error message before. Okay, maybe I need to help the compiler out a bit. But if so, I feel like this would be a Kotlin bug. It seems like it's weird that it can't figure this out. What I'm trying to say is parse file is the parse result dot first. And it's a maybe file. And so if that guy is null, then I wasn't able to parse anything. But if it's not null, that means I did parse something. And yeah, so now it understands this. So I don't know what the problem is with pair, that it wasn't able to figure this out on its own without me helping by introducing a temporary intermediate variable. But whatever, moving on. So we have we did parse the child, so we added to our children parse so far, and then we changed our current input to be whatever remains unparsed. Right? This is, so we parse up to some point, and then by calling this, we were able to make progress and parse a little bit further through our input. So now this advances a little bit. And then I think we just want to loop this. So something like this. Except here, instead of returning the empty set, we're probably going to return this guy. So we keep appending to this guy until we're unable to parse anymore. Oh, and then rather than return input here, we return current input. And then the warning here is they want me to use the Elvis operator, so that's fine. Let's use the Elvis operator. Although I don't really like using the Elvis operator in this situation, but the warning wiggly is bugging me too much, so we're gonna do it just to make the warning wiggly go away. So yeah, I think this implements that. So then with this, I guess all I have to do is I want to say parse all siblings at level 0, right? And then this is probably a set now instead of a list. Set not right? Oh no, that's not right. Okay, so what is the issue here is we have some parse result here, and now what I want to figure out is basically I should have reached the end. So this part, the second path, the input that has not been parsed should be empty. If it's not, I'm just gonna, or I'll use a to-do, I guess, here. Expected to fully parse input, but was left with parse result.second. Otherwise, we did fully parse the input, so we can return parse result.first, which is a set. So we can change the return type of this thing to be a set, and this is going to be empty set. Empty set here. Yeah, okay, let's see. This is actually going to pass. I'll be surprised. Expected this, but got that. Okay, what was the problem? Expected this guy, yeah, but was dir, subdir 1, subdir 2. Okay, I'm not sure what the difference is, so let's copy and paste this and then put them side by side to inspect. Expected all this stuff, but was this stuff instead. Oh, did I need to wrap the whole thing. So yeah, I think this is, the top level is also a set. Okay, let's check if this passes. It passed. Amazing. We're able to parse this. I'm telling you, parse your combinators. It's hard to wrap your head around it, but it's extremely powerful. Let's write the test case for the other guy, for this guy. Fun test can parse example 2. Val input equals something. It's going to be this. The actual is that, and then the expected we will write in a moment. Expected is a set of, so then we have a file node whose name is dir, and it has children, and one of its children is a file named subdir1. Oops. And it has children, which is a file1.ext, does not have children, and it has a subdirectory called subdir1, which also does not have children. And then subdir1 has a sibling called subdir2, and it does have children. And its children, one of its child is called subdir2, and it also has children. And its child is file2.ext, and it has no children. So that's actual, that's expected, and we assert that they are equal. We assert that the actual and the expected, oops, are equal. Have our guy run in test case 2 now, and let's check, cross our fingers, hope it passes. Looks like it passed. Okay, so we are able to parse now. So that's the hard part. The hard part's done. Now we just gotta do the easy part. Easy, quote unquote. So yeah, I guess what I would do, some sort of flat map operator, I think. What I'm thinking is, if you give me a function that takes, and there's going to be a generic type involved, 2 files, and returns some arbitrary type, I'm going to return you a set of those types. So the idea here is like, I'm going to return me and my children. Like there's some sort of combinator here, like you have to no, I guess I need something like a monoid. Let me think about this. It's coming more like a fold now than a flat map. The idea is I need some sort of empty value in my a monoid is basically, a monoid is a data structure such that you have some empty value. So like let me start with something concrete. A monoid is you have some empty value, for example 0, and some operator, for example plus, and the integers with the plus operation form a monoid, where 0 is the empty value. And what that means is if you have a whole bunch of them, like you have a whole bunch of integers, you can combine them with the operator to produce another integer, and the empty value has to have the such property such that when you use the empty value with the operator that you've defined, you end up with your original value again. Right, so 0 and plus form a monoid with the integers, and 1 and multiplication also form a monoid with the integers. So what I'm trying to figure out now is, I have this like sequence of files, right? Like I have a file and then it has its children, and I want to combine them into something. Like basically, in concrete terms, I want to build its fully qualified path. So if I have an empty file, an empty path. I mean, if I have an empty path and then I want to do some sort of reduction on this thing. What would I do? Maybe I'm overthinking it. Maybe I just want another data structure called like a path or something like that, which is a it's just going to be a list of strings. And I just want to say for each of these, I just want to convert them to a path. Get all paths. Yeah, this is probably no need to over generous size this. This is all I need. So how do I construct this? So what I'm going to do is not a list. I guess it's a set here. So what I'm going to do is for each of my children, I'm just going to tell them all to turn into paths. Except I want to flat map this, right? Why is it a list though? I guess they had flat map return a list instead of a set. That's kind of weird. Just turn it to a set. Except before I do that, I also want to prepend my guy to it. Make a new path where what? How do I do this? How do I do string list concatenation in Kotlin? I want my name and then add all. Is it just plus plus? Nope. I don't see a way to append two lists together. Maybe I have to do immutable lists. This is segment singular, but I want it to be plural actually. So I'm just going to refactor rename. Oh, add all returns a boolean? It doesn't return the that's a pain. I really don't like this mutable listing, so I'm gonna look it up in Kotlin append list. The pen does not show up. Well. Alright, well. Come back to this later, but I add this guy, then I add the child segments. Then I can return this path with this thing. This is all the child paths. And I guess I just return this. Get all paths. Okay, so let's write some tests for this. I didn't do TDD this time. I wrote the code first and then now I'm writing the test second. Let's go with this example. Fun tests. What do I call it? Get all paths. Test get all paths. Example 1. So I have this as my input. I'm gonna parse it. This is what I'm testing. So I'm gonna assert that under test dot size is 1, expecting it to be exactly 1. What? I just want what the sole guy. Can I not get that? First, there we go. Okay. So this is the actual all paths, and the expected all paths is going to be a set of I guess it's gonna be half of list of, let's see, dir subdir 1. Oops. And the other guy, dir subdir 2 file.ext. And so I'm going to assert that the actual and the expected are equal. Let's see if this test passes. I think it will. No, it doesn't. Let's copy and paste this to see what went wrong. It was empty. Why was it empty? So let's put debugger right here. And maybe a debugger in here also. And then how do I want to debug this guy. Let's probably find worst step over. Is it this guy? Try this guy. Oh, why did it? That's not what I meant to step over. Or is it? Is this step out? Step into? For step into, step out. What if I just want to hit this line? It doesn't hit that line? Interesting. It doesn't hit that line. Why not? Oh, is there at some point the children is empty? That's probably what it is. Okay, so I think I have to do something like, if I'm a file, then I'm going to, first I'm going to assert that I have no children. Otherwise, I'm gonna just return one path. Which is which consists of just my own name. Otherwise, I assert I'm a directory, and then I can do this algorithm. Okay, so let me run the test now. Hopefully it'll pass. It did not pass. Expected something, and then what did I get instead? Expected this, but was this. Oh, interesting. I quote-unquote automatically get rid of directories. So you know what? That's lucky for me because that's what the problem asked me to do. They only care about files. I didn't intend for this to happen, but like I was expecting to have to filter out to only keep files as a separate step. But if I just call it get all file paths, then this like just automatically does what I needed to do by sheer luck. Get all file paths. So I don't expect to get this empty directory in here. And so I think this test will probably pass now. Yeah, okay, let's do the test case for the other example. Here's the input. And so let's see, it's subdir1 does have a file in this example. File1.ext. Subdir1 doesn't have a file, but subdir2 has a subdir2, and then it has file2.ext. So let's check if this also passes. Let me give a happy all test pass message at the end here. If we hit that line. All test pass. Okay. What should we do for an empty file system? For an empty file system, there should be no paths, I guess, right? That would be the ideal outcome. So let's check if that works. Doesn't work. Oh, did I make I might have a assumption that I shouldn't have here. Oh yeah, okay, so this test doesn't quote-unquote even make sense, because what will happen is when I parse the input, I'll say there are no files. And so then I can't get the first file to call get all paths on. So this test doesn't even make sense. Okay, but now that I have this get all paths function, all I have to do next is for each path figure out its length, including slashes in between each guy, but not including the length, but no slash at the beginning. So this guy, it says this is 32, so let's write a test for that. So list of this. Assert that the path length, maybe get path length, is 32. or assert equal, I guess is what I call not assert that. And so what is the implementation for this? It's gonna be segments. I'm gonna map out of this to their length. And then I'm gonna return the size -1, something like that. Does this work for the empty or not? No, this is going to return -1 for the empty. So if segments is empty, return 0. Now let's return this thing. And then I can probably pull out the return is what it's gonna tell me, yeah. Okay, let's see if this test works. And then let's test that the example, the empty case works. Yep. Okay, so now the idea is I should return after. So I'm gonna give a string like this. I'm gonna parse it. I'm gonna turn it into. I'm gonna get all the paths. I'm gonna get all their lengths, and then I'm gonna return the max length. So I'm gonna do it in 2 stages actually, to just because it seems weird. Like the first thing is I'm gonna say, so give me what is. No, actually, I'm not gonna do it in 2 stages. Never mind. I'm just gonna give the final solution to the problem, I guess. So I'm gonna have a function that get length of longest path from file system, where the file system is represented as string, and then I return an int. And I'm in the spirit of TDD, I'm gonna write the test first. Test this guy for empty FS, empty file system. So what I'm gonna do is, here's my empty file system, I get the actual, and then I would say, what's the actual 0? Because it should be. If I have an empty file system, I should have 0, 0. I should return 0, right, as the instruction here. If there's no file, so I might want to say it's not an empty file system, but it doesn't have files, meaning it only has directories. So let me take here. So I'll just copy example 1, which I guess is this guy, but I'm just going to remove all the files from it. Oops. Why did... That's interesting. I guess it's automatically adding in the converting the things to new line. Actually, that's not bad. Maybe I'll keep it that way. But okay, so then this guy has no file. So we have a directory subdir 1 and subdir 2. No files. I'll call this. I'll do both examples actually. Copy from this one actually. Here's example 2. Oh, I didn't do it that time. That's kind of weird. Okay, so I don't want any files, so I'm going to delete this guy. And I'm going to delete this guy. So let me make sure all these tests get called. Let's check if they pass. I think they'll pass. Nope, they don't pass. Why? Oh, right, because I didn't actually implement this. Because I'm doing TDD. I forgot that I'm doing TDD. But okay, so let me do the other test cases. So This is if there's no files. But then now let's do example 1 and example 2. So example 1 is this guy. And what is the answer? We expect it to be dir subdir2 file execution, right? So it's going to be, rather than countdown, I'm just going to write dir subdir2 slash file.txt, whatever the length of this is what this guy should return. And then for example 2, where's example 2? Here's example 2. It's going to be dir subdir2 subdir2 file2. Let's make sure these guys get called in our test suite. Okay, so this should fail because of the to-do, and then we can just start implementing the to-do at this point. Alright, so all we have to do is parse our file system. If we have no files, I'll just return 0. Otherwise, oops, I make environment file. Otherwise, for each file, we're going to flat map to this. Then we're gonna get their path lengths, and then we're just gonna get the max value for that, right? And I'm just gonna assert that it's not null. I don't think it can be null. The only way it can be null is if this were empty. I guess I add that check, but I don't think it will ever happen though. Oh. Do I still need this, or does it? Yeah, it doesn't realize that isEmpty is related to this. Okay, fine. But let's see if the test passes. It does not pass. Why? Which one does it not pass for? Doesn't pass for this guy. Oh, subdir. I just made a typo. Oh, test case pass. So so I think that's it. I think this solves the question. Let's take a look here. We're interested in finding longest number of characters, absolute path to a given string. I'm just skimming through to make sure I did all the requirements. I didn't miss something. Yeah, I think that does it. I think this solves the all the requirements of the question. What is there to say? So usually when you do these interview questions, they like what the interviewer would like to then ask you is like, what's the runtime performance? What's the memory characteristics of your solution? I think it's actually a little bit hard to analyze, because I think it's hard to analyze with partial combinators what the runtime is. We can try. We can give it a shot. I don't think there's anything interesting to say about the space of this solution. I don't think we uselessly create any data structures. I might be wrong if I skim through the code. So let's focus on the runtime. So I mean, this is obviously O and where n is length of name, which means this guy's also on where n is length of the name, right? Because this guy just calls that guy. What is this guy? This is this depends on how many children you have, I think. So here this is on left of the name. This I believe is all constant time. This depends. This is on list of the name again. This is the number of children. So this is recursive. It's going to call this once on each child and also on itself. And this is the depth of the child. This. Okay, so I mean the runtime is a little bit complicated to express here, but it's something like I'll use like length of name. We call length of name twice. Like the constant doesn't matter too much, so it's length of name plus length of name plus, and then for each child, number of children. We do this basically once for each child, right? This for each child we look at the length of the name again, and we also have to do like a concatenation depending on the depth of the child, basically, or the segments in the child. Called depth of children tree, something like that. I don't know a good name. This is like, so if we care about worst case, this is like whatever the depth of the deepest leaf node is times whatever the longest name is times this is total number of children, actually, like not just my children, but I guess we'll call it descendants rather than children, right? So for each descendant, in the worst case, we're going to do this for every descendant, where this is the length. This takes us the running time, the length of the name, and the depth of the descendant tree. And so this thing is probably, this is negligible compared to this. You could call this n cubed, you know, if you want. If you say like all of these factors are comparable size, and we call it n. Running time of this is n cube. Can we do better than n cube? We might be able to go to n squared if, like, we might be able to shave off this part, depth of children tree, if we like do some sort of lazy thing with the path segment evaluation. But I don't know. I'm pretty fuzzy on this, actually. I'm not sure how to do this analysis. This seems difficult to say what is exactly the runtime. For this guy, the runtime is just, it's basically the length of the output, right? Like, meaning it's the we do something for each segment length, and the thing we do for each segment length is the name of this that's the length of the name. Which, actually, no, can we do this in constant time? Yeah, probably getting the length of a string is probably constant time. So this is actually probably constant time. So it's just, this only depends on how many segments we have. Now we get to the parser part, which is this is the part I did not want to do the runtime analysis of, because it seems like a pain to talk about. Especially because it's mutually recursive, right? This guy's going to call this guy, and then this guy calls back this guy. So let me go a bit more abstract without actually worrying about line by line analysis. What is the parser combinator actually doing? This particular implementation does basically no look ahead, right? Like or constant space look ahead. So sometimes when you're parsing, when you write a parser, you're like, you have to do a look ahead in the sense of the meaning of this token in the text you're parsing might depend on the subsequent on like what happens next later on. I'm trying to think of an example of this that to explain what I mean by that. But I'm having trouble coming up with such an example. Okay, maybe something like an operator. So like in a lot of programming languages, you can do something like this, like right. You have the unary negation operator, but you can also do something like this. It's not really a great example. I'm having trouble coming up with a good example. But the point is like whether this means unary negation or if it means inequality depends on the next character, right? So you have to do a bit of look ahead to figure out the meaning of this character. And depending on the language, in some language you might have to do a lot of look ahead. You might have to like go pretty far to see to find out what this meant. But this language, the parser that we built, isn't like that. It does very little look ahead. Like what it does is like when you reach here, for example, when you're parsing file A at expected level 2, you would say, okay, maybe there's an expected level 3. So you look ahead a little bit. You look ahead up to this point to see, is this a 3? Like, meaning, is this going to be a child of this? If it's not, you don't even need to look at this part. You like as soon as you get to this part, you're just like, okay, so there are no children, so I can finish. I don't need to look any further. So there's very little look ahead. So it's basically linear or near linear, I think, meaning every line you only look at once. Or at most twice, right? Like when I look at this line, I might look ahead here to determine whether or not I need to go forward. If I don't need to go forward, then I would know immediately from looking at this line, and then I can finish processing whatever this is. So I mean that example happens here. If I'm here, I look forward to see, do I need to look at any children? No, I don't. Okay, so I can finish whatever processing I need to do here and then return. If I do need to do some processing, like if I'm here and I look here and I say, oh yeah, this is a child this, then I continue parsing forward, and I never need to like backtrack in a sense, right? Like I never make a wrong assumption and I backtrack and go back and say, actually the interpretation I came up with was wrong. So I think the parsing is linear. It's probably linear time, but I'm hand waving here because it seems like a pain to prove that formally. So I'm just gonna say ON linear. Same thing with this guy for the same reasons, because they call each other. And so if parsing is linear, if these two parser combinators are linear, then this is probably linear. Let's see here. Yeah, it's basically linear. Like we don't really do any looping. We might like this might look. We might look through the strings twice, like once to like convert all the tabs into levels, and then so like we're given a string, right? So we do a first pass through it to like split into split at the new lines, and then another pass to change all the tabs into level calculations, like a name that represents level, and then we do another pass when we actually call this guy. So it's 3 passes, but I think it's linear again. Oops. This is just for testing. These are testing, so they're not part of the runtime. Oh wait, does this guy never get called? I never actually called this test. Let's hope it doesn't fail. No, it doesn't fail. So yeah, I think it's parsing is like I'm gonna hand wave again. At the high level, there's 2 phases. The first phase is walking through this, parsing this whole thing, and that's basically linear of walking through the string once. And then now that we have this tree structure, I think we basically I'm trying to think in terms of the length of the string. Can I say that it's linear in the length of the string? Maybe that's not safe to say. I guess it's n cubed in a very pessimistic sense, but like where all of these things are of equal weight, but I don't feel like they're all of equal weight. Like, I don't know. Let's just say n cubed for now. Hopefully that's good enough, quote unquote. It's certainly I think relatively maintainable, this code base. Like, it's not great because this is again for an interview question, so I'm sort of, there's a lot of to-dos here that I'm not worrying too much about, but this is what I'm concerned about is, like, now that we're talking about this, like, could I do it in linear time? Like, could I have, as I do my one pass through this text, keep track of what I think is like the longest so far or something like that, you know what I mean? That seems difficult though, because like if I can go like super deep into one subdirectory, like if this, you know, like if there's like 20 layers of nesting, I go super deep into one layer, then I pop back up the stack in a sense, and then I go super deep into this guy. I would have to remember. Maybe it's not so difficult to do that. What have I gotten myself into? Oh man, do I want to look into that? I don't think I want to look into it, do I? Shit. The problem is, if I don't do it now, then I'm quote unquote giving myself time to think. Like if I, you know, like if I do a second video tomorrow or something like that, where I try to say, okay, can I do it in one pass? Then I will have had time to sleep on it, and then that kind of screws up the you know, doing it live feel of this video. And this video is already getting a little bit long. What am I at? Like 1.5 hours at this point. You know what? Let's give it a shot. So we're gonna do a second approach where we try for kind of like ON time, linear time, instead of n cubed. N cubed I think is an exaggeration. I don't think it's actually n cubed, but I can't prove it. So can I do implementation where it's easier to demonstrate that it's linear time? Pass. Get length. Okay, so what I'm going to do is I'm going to start by splitting this again into lines. If I have no lines, just gonna return 0. Oh, I forgot to say that this returns something. Now for each line, I'm just gonna copy and paste the tab logic that I had earlier. Lines are level. Yeah, I want this thing. Right, what's the runtime on this? different list of line. For each one, I do this thing. So this is, I mean, this is kind of n squared again, because it's lines.length times whatever the longest line dot, like, you know, whatever the longest guy is, its length. It's n squared, but I don't think that's the right way of thinking of it, because really all I'm doing is I'm looking at each character, like in the original string. Like if you concatenate all of this into one string, like this list of string, if you make it, I'm looking at each character once, basically, right? At most. Like the drop will actually, like, I'll stop as soon as it sees a non-type character, so it's a lot more efficient like that. But in the worst case, in the worst case, it's actually I just look at each character once. So is this not right? Oh. Sequence. And so I'm going to use the same thing with my fast guy here. And actually, converting to a sequence is probably not as efficient, so I'm going to do it like this. Except I don't have an is empty here, so I probably need to do or even is blank. So here, when I do split to sequence, I guess I'm looking at each character once, and then when I do this thing, I'm also looking at each character once again. So far I'm in like 2n, right? Still linear time. I guess I start -1. And then I'm saying, what I'm going to do is I'm going to iterate over lines of length. Do I have a stack? Or is a list basically a stack? I guess I'll use a list as basically a stack. What I'm going to do is cur path, let's see. Actually, I don't need current level because I can infer current level from current path. So if I make this a mutable list. Then I want to append the this segment basically to the current path. Otherwise what? Otherwise I don't know yet. Now that I've done that, I want to see, like, is this guy a file? So the way I do that is, does this guy contain? Does it contain? Oh no, I need second dot contain a period. Maybe I can document this a bit by saying this file. So if it's a file, then I want to see this path is equal to cur path and if this path length is greater than longest path seen so far, then we just update the longest path seen so far with this path length. Otherwise, if it's not a file, we just keep going, I guess. Okay, so what are the other cases? If it dot first is let me think about this. When this is empty and I see I should see like this guy is at level 0. So then subsequently cur path, this will have this list will have length 1. Then when this comes, this is length 1, so I'm adding it. Then when this guy comes, let me do this example. This guy comes, so I'll add it. And then when I get here, this guy has a lower level. So it dot first is less than cur path. Okay, so is there a way to remove the last element? So do I want less than or do I want less than or equal? This is what I have to figure out. Cur path will be cur path dot length, or cur path dot size will be 0. When I encounter this has level 0. So I append, and now cur path has size 1. This has cur path has size 1. This has level 1. I append cur path has size 2. Cur path has size 2. This has level 2. I append. Now cur path has size 3. Cur path has size 3, which is these 3 nodes. This has level 2, so I want to drop one element from cur path. So now cur path has size 2 and this is size 2, which is these, like the cur path has size 2 because it has this and this guy, and then I want to append this guy. Okay, so I probably want to do this first actually, and then it should always be the case that now they're equal, I think. And so this to do is like this. And then can I just return now the longest path seen? Was this the easier way to do it? So let's do this test here. I'm going to rewrite these guys to be reusable tests, in the sense that if you give me the function to test, I'll test it. rather than hard code these guys to test the specific function, I can test any implementation of this. So I don't know how to do a method reference in This is how we do it. Okay. So this should test the old thing, the old method, and then we also want to test my new guy. Is that not what I call it? I call it fast get, not get fast. Let's see if this works. I really hope this works because I don't want to spend a lot of time debugging this. Oh, no, okay. Oh no, that's a bad sign. That sounds like I have an infinite loop somewhere. Where do I have an infinite loop? Just let it run for a while, and then I'll pause it somewhere. Oh, does drop last return a new list, or does it return the same list? Okay, let's do it like this, because oh, come on. All test pass. Wow, first shot, first try. There's no way, right? Like, there's gotta be a bug. Let me introduce a bug on purpose. Where can I do it? Here's a bug on purpose. No, it really is running that code. And if I do like this, or okay, so that's pretty hilarious. I spent like what, an hour and a half writing this implementation, and then I write this other implementation in what, 20 minutes, and I'm pretty sure this is linear time. I don't know, it has a nested while loop here. What is this? I guess it's n squared in the worst case. Like it's an n squared that isn't as scary as it sounds, because what it does is it looks at every character at least once, right? But then there's a part where it says, like, depending on how many segments you have. So if you have a very deep path segment, like if you have a directory structure that just goes like super deep like this, then it has to, like, it potentially has to pop off a lot of paths off the stack here when it goes back. Like if you have this and then the next entry is like this, it has to pop off foo.x, s, s, sd, f, and so on. Like it, so So in theory, like you know, it looks at every character and to create this big stack, and then it has to gradually pop off each of these stack. But each, I guess that might be linear though, still, because the maximum depth of the stack is the length of the string so far, right? Like I got this far. Like the number of subdirectories can't be longer than the number of characters up until that point. But I guess it could be n squared, because the worst case is like I look at one directory, then I have to pop that, then I go 2 to, and then I pop all these, and 3, and then pop all these. No, but then that behavior won't ever actually happen, I guess. Because every character, like every word or node either adds one or moves one. Okay, so I guess what I can do to prove that is if I write the code like this. So I'm saying, if it's less, then I should pop it, and at that point it should be equal. No, that's not true. That's not true, because like this case, right? I need to pop off a lot to get back to here. So that means I can go I can parse the string pretty far to get to this, and then I will have to pop off a lot, and the amount I pop off could be relative to how deep in the string I've been so far. But then when I get here, like that, like if a slash bar was here, I never have to revisit this again. Like even if I pop a whole bunch of stuff on like so that this also becomes deep, like with a different directory structure, like instead of a slash b, it's like a slash c slash whatever. Then the most I will have to pop is up to here, like meaning up to wherever I first saw this node. I never have to pop all the way back here. So I go here and I go back. Yeah, so what's not the case is it doesn't go like here and then back and then here again and then back and then here again and back and so on. So it's not n squared. I think it is linear, because whenever I go somewhere, I might have to, like if I reach this point, I might have to do processing whose time is linear relative to this, but then I never have to look at this again. I only need to look forward from that point on. So this even though it's unnested, it's not n squared. I think it's linear. And then there's no other loops, so there's this thing, this map. I have to calculate the length. Yeah. Does that make it n squared? Let me think about this. I'm leaning towards no, because I think, like, let's say I'm trying to calculate the length of this guy. I would have to walk through. Oh, I guess it could be n squared, in the sense of, let's say I have a super deep directory structure, and then I have a file like here. And then I have another super deep directory structure, which, like, I mean the same directory. Like, so these are siblings, right? Like foo and then foo3. If these are all siblings, then I would recount all of these again, then add this guy, recount all these again, then add the. Okay. I could fix that with some caching, but is it even worth doing that? I mean, it might be. Like if the interviewer tells me, yeah, you know, like maybe recomputing all this is expensive, then what I could do is when I append something to here, I can also compute what the length up to this point is. Why don't I just do that? Let's do it. Let me think about this. I think I have to handle the empty case. So if suppose this guy. And what I would add is +1 plus this, right, for the 1 for the separator. Then this guy's length is going to be cur path dot last dot first Okay, let's see if this still passes. Oops, I didn't mean to add a debugger. It still passes. Okay, so there we go. So we got rid of the loop. So now it's pretty confidently linear time. Okay, so there you have it. I guess now it took me about another half an hour. So I spent 1.5 hours doing this implementation. Then I spent, which is like O cube, but it's not as bad as it sounds, O cube. And then we got this guy who is ON. And it took me about half an hour to do. This guy, like I say it's O cube, but it's probably pretty linear. Like I don't think it's even O squared. It's just I don't know how to prove it. Like the structure of the program makes it hard to do that analysis. Whereas this implementation was written so that it's much easier to do the runtime analysis. Although there was a bit of a struggle here to prove, that thing about going forward and backwards needs a little bit of deeper analysis to be confident in. But the nice thing about the first implementation, though, is I think it's a lot more extensible for future features, because like we actually build a model, right? Like the this data structure here, where I'm trying to scroll up here, this thing, we can actually do things like we can reuse this file structure to do other things if we wanted to, right? Like we can expand this to do a full, like if this Google question were like to implement some OS or something like that, this could be reused for that. Whereas the second solution, the fast solution, could not be reused for that purpose, because it doesn't build a model. But if we're confident, if for some reason we're in a data performance critical path, like if we're saying all I care about is I just want the length, I don't care about anything else, I just want this length and I need it to be as fast as possible, well, that's what the second implementation is for. So yeah, it was quite a question. It's a lot more involved than some of the other ones I did, but so that's why this video is quite a bit longer. I hope you guys had fun working through this with me. Let me know if you guys came up with a different solution. I'd be interested to see what other people have done. Let me know if you guys did the analysis on this and then you came up, if you disagree with me, if you say no, it really is n cubed or whatever. Or if you figure out actually it is linear, I would like to see a proof of that if possible. And yeah, so thanks for watching, and hopefully I'll catch you guys next time.